At the top of the coaster, all of the energy is just potential energy. As the marble travels down the coaster, potential energy is transformed into kinetic energy. At the midway point, potential energy and kinetic energy are equal, but also energy is being transformed into thermal energy. The highest kinetic energy is at the bottom of the coaster, where all of the energy is transformed into either thermal energy or kinetic energy. The total energy of the system is kept constant throughout the entire coaster. And the mechanical energy is the sum of the potential and kinetic energy.
As we see here, we have three graphs: top of the roller coaster, midway, and bottom of the roller coaster. In blue, we have potential energy. Green, we have kinetic. Mechanical energy is in the purple. Heat or thermal energy is in the red, and total energy is in the orange. At the top of the roller coaster, we have the highest potential energy because it's starting at rest and it has not moved yet, so it has built up the most potential energy at any point in the roller coaster. Kinetic energy is at 0 because it hasn't started moving yet, so there's no kinetic energy to have. The mechanical energy at the top of the roller coaster will be equal to the potential because it is equal to potential plus kinetic, but since kinetic is 0, we'll just have potential. Heat energy is also 0 because we have not moved yet, so there's no friction to be built up or gained into the heat energy, and the total energy is going to be equal to the mechanical energy because that's the only energy we have at the top of the roller coaster. Midway down the roller coaster, our potential energy has decreased because we are now moving. Kinetic energy is getting bigger because there's more energy to build up as we are moving. Mechanical energy is now equal to potential plus kinetic, and heat energy is increasing because our friction is increasing as we move down the roller coaster, not only from the marble on the foam, but the sticks in the foundation of the roller coaster. Total energy is remaining constant because it is conserved. The bottom of the roller coaster is the lowest point for potential energy. Kinetic energy has decreased because there's not much more to move, and mechanical energy is now the sum of those two, which is at its lowest point. Heat energy has climbed to its highest point because of all the friction built up over the whole entire ride, and total energy, again, is constant because it's conserved throughout the whole thing. As we can see, mechanical energy is at different values throughout the whole roller coaster, so it's not conserved. It loses energy due to thermal and friction.